more projectile motion. I'm always going to follow the same steps. I can see that this is going to be one of those ones where I need to do components because it was launched on an angle. But if I just follow the steps and grind it out, I can deal with any curves as they come, although this one looks kind of straightforward. Always going to doodle a picture, so I got a baseball thrown at 10 meters per second on the 30-degree angle, so the 30 fits in there. It says that it's thrown from a height of 2, so the ground is down here somewhere. This ball is going to follow a nice parabola, crash into the ground there. So the 2 meters is my vertical distance. Oops, a little bit messy, and I'm curious about this distance. How far sideways does it go? The question mark is in the horizontal component, so I'm going to start with the vertical. Vertically, it doesn't say it's on the moon, so I know that the gravity is 9.8, and that's pointed down. It lands 2 meters than where it started from, so even though it started up in the air, because it landed lower, its displacement's actually down. So my displacement is 2 meters, also in the down direction. It was fired on this funny angle. So the upward component of how fast it was going originally is that line in purple. We'll eventually need the horizontal component. That's going to be that line in red. If we look at the purple one, if we keep drawing our triangle the same way, keep being given the angle in the same descriptor, how many degrees away from the horizontal it is, then the vertical always ends up being a sine relationship. 10 meters per second, let's say 10 multiplied by the sine of 30, and that's in meters per second pointed up. And like all projectile motion, I'm going to use that for time. To deal with the opposite directions, I have to use opposite signs. Just to do it differently this time, I'm going to make down positive. So I'm going to say the A is 9.8, the D is 2, and if I do a little bit of math in my head, 10 multiplied by the sine of 30 is 5. I'm going to say the V1 is -5. If you've already done it the other way with the signs, don't change it. We'll agree on our answer when we get to the end. D is V1T plus 1/2 AT squared. So I would say positive 2 equals -5 times T plus 1/2 9.8 T squared. If I put that in standard form, the 4.9 T squared is okay. It's already positive. The 5 is there on the right side of the equation. It's negative. I need to flip the 2 over by subtracting, so I get a -2 equals 0. You could flip the Desmos and graph it and pick out the x-intercepts, or you could use your quadratic formula. At this point, you can figure out how to solve for time. We should agree that the positive root is 1.33. Regardless of how you set up your signs, whether you did down as positive or down as negative, we should agree on the 1.33 seconds. And as we've seen before, the horizontal isn't too bad to work with. V is d over t, or we're looking for the distance. The distance is going to be v multiplied by t. If we always draw it the same way, we're always going to get the same trig. The horizontal velocity is adjacent to the 30-degree angle, so our horizontal speed is going to be 10 multiplied by the cos of 30. The time we just figured out was 1.33 seconds. So it ends up, when we multiply that out within rounding, 11.5 meters. The baseball lands 11.5 meters away.